All right, I have a feeling you're here to graph the cosine curve. So it's really pretty easy. There's going to be 5 points that we're going to get. And once we get those 5 points, just like we did with the sine curve, and I'll link that, that video here down below. If you're not sure how to graph the sine curve, that'll help also. But you just need these 5 points, and then it just keeps repeating. You'll see what I mean. So let's take a look at what I like to call the plain vanilla. The real simple, the boring y equals cosine x. There's no transformations at all. So the first thing I always ask students is, where does it, quote, start? Where does it start? So if you think of this axis as being the time axis, the starting point would be right in here when time is 0. So where does it start? The cosine curve, unlike the sine curve, the sine curve starts at 0, but cosine starts at 1. It starts at its highest point. Now, how long does it take for cosine to finish one complete cycle? Well, think about that unit circle. All the way around the unit circle is how many radians? It's 360 degrees, or 2 pi radians. So 2 pi is when the period, it's called the period. The period of cosine is 2 pi in length. So I'm going to go all the way over here. We need 4 quadrants, so it'll be 1, 2, 3, 4. It'll be the fifth hash mark, basically, and this, if you count 0 as the first hash mark. All right, and it's going to finish there also. All right, so we've got 2 of our 5 dots. Remember at the beginning of this video I said there's 5 dots we need. So there's my start and my finish. All right, you with me so far? Now, in the middle of this thing, right here, it bottoms out. This is a giant valley. It goes to its lowest point in the middle. So I always tell students to go and get that point next. So this one over here, let me highlight it for you. This was the first one I found. This was the second one. And then this was number 3 here. Okay, then what happens in the middle? Well, in the middle is where it hits the middle, which is the x-axis. All right, so you're looking at this and you're thinking, Mr. White, the cosine curve is not a V shape. It's not an absolute value graph. Well, you're right. It is the same curve as the sine curve. It just starts at a different place. So here I'm going to graph it like this. It goes down here. It goes horizontal just for a moment. Comes in here. And then it goes horizontal again at the top. Notice how I tried to draw that real carefully. So it goes horizontal here just for a moment, here and here. And by the way, it cuts through at a 45 degree. If you're using a scale like I am, it's a 45. So I always try to think about that when I'm drawing it so that I do a good job drawing it. Now, as you know, the cosine curve is, it's called sinusoidal or periodic. It just keeps going and going. So it will go right here, 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 here. You see how you can just keep drawing these dots and it just keeps going. Also, you can go backwards and it just keeps going this way as well. All right, so before we go on to the next problem, I want to zoom in here and just have you look at something. You see what you see there? That looks a heck of a lot like a sine curve, right? Because sine starts, goes up, down, up. There's a sine curve. Well, the cosine curve is merely a sine curve shifted to the right by pi over 2, because this is a half of a pi, by the way. All right, you know what I didn't do? I didn't label my x-axis, so let's make sure we do that. This was 2 pi. This was pi, because that's right in the middle. Right? In the middle of 2 and 0 is 1 pi. This would be a half of a pi. And then this would be 1.5 pi, which is 3 pi over 2. So this back here, what made me think of it was how that is at negative pi over 2 over there. So this is what I call the plain vanilla cosine curve without any transformations at all. Y equals cosine x. Now we're going to start moving this around. I do want to bring up one more vocabulary word, amplitude. Amplitude is how high and how low it goes. So this thing goes up 1, down 1, up 1, down 1, and so on. So the amplitude is 2. The amplitude is 2. So some of them that we do today will have some different amplitudes, so that should help you understand that. So I bet your teacher has you write all these, the period, the amplitude, horizontal shift, vertical shift, any sort of stretch, those sorts of things. And we'll get to all that here in a moment. All right, so let's go to this next one. So what does a number at the end of any function do? Like an x squared minus 2. An x squared is a parabola. X squared minus 2 moves it down by 2. So that's all we need to do with the cosine curve. So what I encourage you to do, I'm going to call this -1, and this will be my -2. This will be -3. All right, is draw a dotted line there. Some teachers call it the midline or the center line there. But that's where we're going to center all of our 5 dots. Remember, we have to do 5 dots now. Now, the period on this is still 2 pi. And the reason is because there's no extra funny business on the inside there with that x, and we'll see some of those in a sec. The amplitude on this one comes from the number out front. It's still 1. This graph is going to go up 1, down 1, folks. There is a vertical shift down by 2, and that's why we moved that dot down. Now, let me grab this here. Remember, it used to be up 1, and that's where it started. It used to start at 1, but now it's going to start 1 higher than the midline, which is right where I've got that dot there. So let's fill that in, nice bright red. Okay, so that's there. So the period is 2 pi, which means it's going to finish right where it started after 2 pi time goes by, or 2 pi radians here. So I'm going to put a dot right there. Notice I have my 4 quadrants. 1, 2, 3, 4. See, here's number 4, 3, 2, 1. My 4 quadrants. That's just that unit circle, the quadrants of the unit circle. All right, so we need 5 hash marks. 1, 2, 3, 4, 5 to get our 5 magic dots. All right, let's keep going. The next thing we did, remember, I went to the middle. I went to the middle, which was right here. And instead of being up 1 from the midline, we're going to go down 1 from the midline. So I'm going to put it right there. And then, do you remember where the 4th and 5th were? They were on that middle, on the x-axis previously, but it's going to be right here on this one. So we can now go ahead and graph cosine x minus 2. And of course, it would keep going. If our teacher wanted us to graph a couple periods of it, we just could keep going. But there's about 1.5 periods of it. All right, let's continue on. All right, what does this graph look like? Well, I'm putting a number out front this time. That's not the period. The period is still 2 pi. The period comes from this in here. The amplitude this time, the amplitude, I was trying to abbreviate there, is 3. So we're going to go up 3, down 3 from the midline. Now there is nothing at the end here, so the midline is still the x-axis. So I'm not even going to bother to do anything there. For purposes of showing you an exaggerated stretch, I think I'm going to label it like this one for you. 2, 3, -1, -2, -3. I'm going to go 1, 2, 3, 4. And this will be my 2 pi. Just like it was in the very first example, that plain vanilla. But this time, instead of starting here, we are stretching all the way up to 3. All the way up to 3. I'm going to put a nice big dot there for you. And then you always end at the same place. So I went to the end of the period, and I went all the way up. Now in the middle, I have to go down 3. So this is very amplified, right? You've probably heard that term before, right? With audio, with sound, music, you amplify it, and it gets louder. The sound waves get stretched this way, makes them louder. It doesn't change their frequency. Frequency is this way if it gets higher and lower pitch. Okay, and then in the middle, we put our dots in the middle. And if you want, we could label this. This is pi over 2. This is pi. This is 3 pi over 2. And we do our cosine curve. So this one's kind of really really stretched, but it still is a cosine curve, right? And you could continue graphing it if you wanted. We could go into negative territory as well. You get the idea. All right, let's see what's up next. Uh-oh. Now I've stuck a number on the inside. This affects the period. This affects the period. So how do we find the new period? Well, what I always tell my students is you take the 2x and you set it equal to 2 pi because you're asking, hey, when is that thing going to finish? When will it equal 2 pi? Because cosine 2 pi is right back where we started again. So then if you divide by 2, you get x equals pi over 2. I'm sorry, get x equals pi in this example. Now, a lot of teachers teach this as the b value, which is a good way to do it. It's the b value. And the period is always 2 pi over b. So you can use that nifty little shortcut formula to do it also. Either way, it's pi. So I still have to cut it into quarters. I still need my 5 magic points, but I label the end of this pi this time, which means this would be pi over 2, because that's in the middle, right? This would be pi over 4, and this would be 3 pi over 4. So you have to count by quarters to get those dots. Now the amplitude in this is still 1. So the amplitude is still 1. This was the period, by the way. And we're going to go up 1 and we're going to go down 1. So let me grab my red pen. Here we go. Where's the first dot go? It always starts at either 1, or we might see one later that starts at -1 actually, but it's not going to start at 0. That's my point. It's not going to start at 0. Wherever it starts is the same place it finishes. And then in the middle, you go all the way down to the bottom there. And then in the middle, you hit the middle. Simple. You get your 5 magic dots. Hopefully this is starting to feel crazy easy. Don't worry, we're going to mix lots of things together, so don't start tuning out yet, because you're not a pro just yet. You got another 5 minutes or so, and then you'll be a pro. All right. So there's cosine 2x. I know it looks very similar to that first example I did, but I relabeled it, right? I have it as 1 pi at the end, and then it keeps going. So I just relabeled it, which makes it a little bit different. Okay, let's go to the next one. All right, negative cosine x over 2. Uh-oh. So this is going to affect the period in here. And then what does the negative out front do? It doesn't change the amplitude. The amplitude is still 1. It's just going to be a reflection. This whole thing's going to be flipped over. So instead of starting at 1, it'll start at -1. Let's figure out the period. To figure out the period, you take this stuff here and you set it equal to 2 pi. And then we multiply by 2. So we see this is a very slow, oops, having troubles writing there. Let me fix that for you. X equals 4 pi. This is a very slow graph. That last graph, this one right here, I meant to say this, so this always helps students when I say this. You ready? Listen. This graph was twice as fast. It finished in half the time. It was twice as fast. Because of that too, it moved it right along. Okay? Now this last one, this next one, this is a major drag. Dividing by 2 slows it down, so it takes twice as long to finish. Instead of 2 pi, it's 4 pi. All right, so I'm going to label this a little bit different just to show you what a drag that divide by 2 is. Here's 1, here's -1. I'll keep that the same. All right, so I think I did 1, 2, 3, 4, 5, 6. 1, 2, 3. All right. Yeah, I got it. Okay. So this will be pi here. I'm sorry, this will be 2 pi. Let me start again. This will be 4 pi right here. All right, this is 2 pi just like it was before. So this is the same scale as the very first one I did. This one's pi, and this is 3 pi here. So wherever it starts is, this number out front. So it ends up starting down below this time. So it starts at -1. which means it's going to finish at -1. Way the heck over there at 4 pi. Now in the middle is where it's at the extreme other side of the middle line. And then in the middle, it's in the middle. There we go. So this is a cosine curve that's very slow. There it is. This is a horizontal stretch. Horizontal stretch is what's going on here. All right, let's move this right along. We have 3 more examples for you that mix up some different things. So this one's definitely different. What's going on here? This is a horizontal. It's called a phase shift. If you've ever heard of something being out of phase, it's where it's like blurred a little bit. It's a little bit off. Like if you have this and then you have this here, you see how those aren't quite on top of each other? They're out of phase. So we are shifting our curve over a little bit is what we're going to do. So this is going to be to the left by pi over 4. And you might be thinking, but I see a plus sign. Why is it to the left? It's always the opposite of what you see. You're finding a 0. You're finding an x-intercept. So you set it equal to 0. You subtract pi over 4 to the other side. It becomes negative pi over 4. So we're going to have to go to the left by pi over 4. All right, so I am going to label this the same as before, okay? So this will be pi. This will be pi over 2, 3 pi over 2, and this is 2 pi right here. So do you notice how I made 2 blocks? Oops. I made 2 blocks. So this would be pi over 4, which means this would be negative pi over 4. All right, you got to make sure your blocks work out here nice and even, that they're a good even spacing. Now the amplitude is 4. There is no vertical shift. We haven't had one of those in a while, but that's okay. We're just trying to understand what all these different numbers do. I have a feeling in the last couple examples, I'll have some real good, whole bunch of things mixed in. All right, so we go to our beginning. Our beginning is not here, not at 4 there. It's going to be here because remember, we're shifting to the left by pi over 4. Now, instead of finishing at 2 pi, it's going to be to the left by pi over 4. Right? So that ends up being, let's see, so that would be 7 pi over 4, because 8 pi over 4 is the same as 2, so 1 less would be 7 pi over 4. All right, then in the middle of all of that, which would be right here, is when it goes all the way to negative 4. All the way to negative 4. And then in the middle, it hits the middle. So that would be right here and right here. All right, so this is a very similar graph to what we graphed earlier that had an amplitude of 3. It was stretched, but this one is also moved over to the left this time. All right, and I graphed one period, and of course we could keep graphing more periods if we were asked to. All right, 2 more examples. Oh my goodness, we have how many things going on here? We have 4 things going on, 4 things in one graph. So I bet your teacher has some of these on your homework assignment, and you're wondering how you're going to do this. Now, I will tell you, when I first started teaching trigonometry, I taught something wrong. Can you believe it? I just didn't read the book carefully enough to remind myself. This is not a left by pi over or by pi. It's not left by pi. You have to factor the 2 out. You factor the 2 out first. You divide by 2 and you factor it. So now it's left by pi over 2. All right, the period. To figure out the period, we use that b value. B equals 2 in this example. So we end up doing 2 pi over b. That is 1 pi. So the period is 1 pi. We are reflected because of that minus sign. The amplitude is going to be 1. And we have a vertical shift down by 1. That's this guy right here. So that's the first thing I want to do is I want to go, let's see, I'm going to call this, I like to kind of stretch this out for you so you can see it better. So here's -1. This is -1. That's my midline. All right. And our period is pretty quick. It's pi. But we also have to go to the left by pi over 2. So what do we want to do? Let's call this negative pi over 2. That means this would be pi over 2, and this would be pi right here. Okay? So then this would be 3 pi over 2, and this would be 2 pi. All right, let's see how this works. Where's our first dot go? I know this is a lot, isn't it? Our first dot, because we're shifting to the left by pi over 2, our first dot is going to be on that vertical dotted line that I just drew. Now remember, this thing's upside down and the amplitude is 1. So we're going to go down 1. And then we always finish where we started. So remember, the period is 1 pi. So I have to measure from here to here has to be 1 pi. So a half here, a half there, that adds up to 1, right? 1 pi total. And then in the middle is where we go all the way up to our highest point this time. So here's -1, 1. And then in the middle, we hit the middle. All right. So then you could keep drawing all your magic moments here. Oops, I think I feel like I did that one wrong. Then that would be, all right, pi over 2. This would be right here. There we go. There we go. All right, and then the middle. So I think I was right. I didn't have it labeled, so I confused myself. Here we go. You see how condensed this is. It's a very short period, only pi instead of 2 pi. So it's twice as fast, and we moved the graph over some, and it was upside down. All right, we got one more example. All right. By the way, when the amplitude is 4, some students think, because it's going up 4, down 4, the amplitude would be 8. But the amplitude is just how much it's going up and down. So this is oscillating 4 up, 4 down, 4 up and down. That's the amplitude. So the amplitude here is 4. The period, this one has that half. Remember what that was then? It's half as fast. So this ends up being 4 pi if you work it through. Now, this is down by 1 again because of this here. No reflection this time, so we're going to start up high at 4 this time, actually at 3, but we'll get there in a second. What about the factoring? I did this on purpose because students always ask me about this. How do I take and factor the 1/2 out and figure out what the heck that fraction would be right there? So if you're confused as to whether it's going to be, pi over 8 or pi over 2, which is it? Here's what you do. It's really easy. You take your pi over 4 and you are dividing a half out of it. You're factoring out a half. All right, so then most of you know, oh, at this point it's keep, change, flip. All right, so it's 2 over 1. 2 goes into 4 2 times. You multiply the top and multiply the bottom. You get pi over 2. So pi over 2 is what would go in there. You could always check your work by launching your missiles, and a half times pi over 2 is indeed negative pi over 4. All right, so we are to the right by pi over 2. We're to the right by pi over 2. All right, we always start with the midline. So we're going to go down to -1 and make sure we know where the middle of the graph is. Now we're going to have to go all the way down to 5 because remember this thing is a very large amplitude. So we're going to be swinging up 4, down 4, up 4, down 4. So we need lots of dots here. There's 1, 2, 3. Here's -3. Here's -5. All right, let's figure out where this first dot will go. Let's see, our period is 4 pi. All right, so we could label, this could be pi. Whoops. Here's 2 pi. Here's 3 pi. And here's 4 pi. So I'm really stretching this out. And part of the reason why I'm doing that is because I have to shift to the right by pi over 2. I have to shift to the right by pi over 2. So here's my pi over 2 shifted to the right. Now I had to get my first dot. First dot here is not at 1, it's at 4. But it's 4 up from the midline, right? You're probably screaming at your phone right now. So it's 4 up from the midline. So if you measure this, it's 4 blocks, plus 4 minus 4. So then we got to go 4 down for the next one, and that's going to be way down there at -5. Some teachers like to do this, and I think this is also a good idea, is you can draw a second set of dotted lines to kind of have this channel where your oscillating function stays on the road here. So that's not a bad idea. Now, we need to go 4 pi, which would be way the heck over here. Notice how I went another half of a pi, because this way over here is 5 pi. I went another half beyond my 4 pi hash mark. That was important. Which means my middle is right here, and my middle would be all the way down here. Don't forget, this is the center. So I went up 4 and down 4. Now I go to the center, which would be right here, and would be right here, and I'm ready to graph my cosine curve. All right, and of course you could keep going here if you wanted to, either direction. So if you can graph sine, you can graph cosine. If this is the first video you came across, well, now you're pretty much a pro at the sine curve also. So I will be sure to link my video on the sine function at the end of this, so you can easily find it. Really, it's just all about getting those couple of dots, those 5 dots, and then the graph is so easy to do. All right, well, I hope you've enjoyed this video. Be sure to like and subscribe and come back to Endpoint Math. I'm here to help. Until next time.